Okay, good morning. This is Algebra 2, and we are covering lesson 3.4, solving systems by elimination. And you're going to be able to solve a system of equations using the elimination method. And, the elimination method is where you eliminate a variable by multiplying or dividing to get opposite coefficients. So why don't I put that here? Elimination, let's pull this down. Elimination is a variable. Or to eliminate a variable. Let's say it that way. To eliminate a variable. To eliminate a variable. Do so by multiplying or dividing to get the opposite coefficients. Now you've been doing this when in your undoing process, when you're undoing equations. So this is very similar to that, okay? All right, and this video supports Algebra 2 IXL Lesson Skill E.8. And remember, upload your lesson notes to me. You can use the Student View Dropbox, or you can use my email address and send it to my email. But I want it this time by Wednesday, October 7, because if you remember, this is the end of the quarter, and so this is the last day that we can turn it in. So make sure that you do that. Okay? All right, so let's do our first system. So solve the, and I had a little boo-boo there, solve the system using the elimination method, and we're going to check. Okay. So with the elimination method, always check. Always. All right? And when I say always check, at least check during your test, if nothing else. If you check during your tests, you're going to get a really good score. And it'd be kind of nice to end this quarter with a really good score on your test. You do this, if you check, you're going to be in good shape. All right? All right, the goal, your goal is to have opposite coefficients. And remember, that's the number in front of the variable, and then you combine the equations. And that causes an elimination of one of the variables. So we're going to do that over here to the left. All right. So you look at the two equations, and we've got them kind of racked and stacked here so that the x's are pretty much together, the y's are together, and the constants are together. And what we're literally going to do is we're going to combine these two equations, just as if we were adding them together. So that's what we're going to do. Now let's just look at what we've got for terms. So if you look at the x's, you'll notice that the coefficient for the first equation is negative 6. X is, of course, the variable. And the coefficient for the bottom one is 6. So they are opposites already, which is good. That's what you want. You want opposites, okay? So that's the golden rule. This is already set up for you that way. So all you have to do is go ahead and combine. So negative 6x and positive 6x cancel. And 5y and 4y is 9y, right? And 1 and negative 10, or 1 minus 10 is negative 9. Okay. And then divide by 9 on both sides. And you end up with 1y, which is what you want. You've isolated the variable, and y equals negative 1. So now you know what the y is, okay? And so you can plug this in. We're going to plug this into either of the two equations at the top and solve for x. All right? So let's just write the first equation here. It's the smaller equation, meaning that the numbers are a little bit lower. So, you know, we always want to go as easy as we can with this stuff. So let's take negative 6x plus 5y. It'll be our first equation to use anyway, and we're going to use them both. But always think easy when you do these. All right. So you're going to plug in then. You're going to plug in that negative 1 for your y. Okay. So you'll have negative 6x plus 5 times negative 1. And that equals 1, we hope. Let's see. So negative 6x, this is negative 5. 5 times negative 1 is negative 5 equals 1. So we're going to add 5 to both sides. And, you know, here's elimination. This is a good example of elimination that's going on in your undoing. So, you know, this is a good crossover for you to think about it that way. So you now have negative 6x equals 1 plus 5 is 6. And then you divide by negative 6 on both sides. And you end up with 1x, because negative 6 divided by negative 6 is 1. And 6 divided by negative 6 is, is negative 1. Okay, so this is negative and negative. This is positive and negative. So x equals negative 1. So you've got both the x and y being negative 1. So let's just check this. So let's do our check. So let's just take the first equation. So that's negative 6x plus 5y equals 1. And we're going to plug in negative 1 for your x plus 5 times, again, negative 1 for the y. And that's going to equal 1, we hope. So this would be negative times negative positive 6. 5 times negative 1 is positive times a negative, so that's a negative 5. And of course, that equals 1. So that checks. So that's the first equation. Second equation is 6x plus 4y equals negative 10. And again, you're going to plug in negative 1 for the x and negative 1 for the y. And that equals negative 10 again, we hope. So 6 times negative 1 is negative 6. 4 times negative 1 is negative 4. And indeed, negative 6 and negative 4 equals negative 10. So it checks. So if you check like this, just like I did here, with every single equation in the test that you're going to be doing, you're going to have 100%. That's all you need to do. Check, check, check. Okay? All right. So let's look at the next one. So the next one, you know, we look for, again, the easiest thing that we can get rid of or eliminate. And before we saw that we had two x terms in the A problems that were the same as each other, except one was positive and one was negative. Here, we've got 8x and negative 3x. That doesn't help. But this is your easier number, the y's. Because the y's, you'll notice they're both the same. They have the same coefficient, okay? 1. The problem is one of them needs to be negative. And so since that's the case, to change this 1 from positive to negative, I have to multiply that entire equation times negative 1. And what I'm going to do is I'm going to distribute that negative 1 to the negative 3 and to the 1y and to the negative 5. Okay? And the reason I'm making the second equation, I'm multiplying it times negative 1 versus the top one, is that if I'm going to make a change, I'm going to make it to the simpler equation. Again, we go easiest, the easiest way we can. These terms are lower for the most part. In fact, they are, except for the y. Okay, so let's distribute. First, I'm going to rewrite my top equation, which is 8x. Let's just put a line here. 8x plus y equals negative 1. We'll call it 1y because we're going to have that in play. And then distributing the negative 1 times negative 3, that's going to give us negative 1, negative times negative, that's going to give us positive 3x. Negative 1 times positive 1y, that's going to give us negative 1y. And the negative 1 times negative 5 is going to give us positive 5. Now we're going to combine them. So 8x and 3, 8, 9, 10, 11. Okay, 11 x's. 1y and negative 1y cancel. They're eliminated. And let's see. Oh, this was negative 16 up here. Make sure we got these correct. The terms are not correct. So now I have negative 16 and positive 5. That comes out to, let's see here. And this is negative 5. So, oh, that's positive 5. I'm sorry. Positive 5. So that's going to come out to negative 11, right? And we're going to divide by 11 on both sides. And when we divide by 11 on both sides, we get 1x equals negative 1. So we got negative 1 again as our answer, okay? So now we're going to, so we combined, right? Now we're just going to pick an equation to put this x is negative 1 into. Okay, let's see here. So looking at this, let's do the negative 3x plus y equals 5. Why? Because it's the smaller equation. It's just a little easier. So negative 3x plus y. Notice I go back to the original one. You don't want to mess with these down here because you could have made some kind of error in them, and you want to make sure that you keep it as simple as you can so you can check for your errors a little more easily. So negative 3x plus y equals negative 5, okay? And then we're going to substitute the negative 1 for the x. So we have negative 3 times negative 1 plus y equals negative 5. So negative 3 times negative 1 is positive 3. 3 plus y equals negative 5. And then we're going to subtract 3 from both sides. And we get y equals negative 8. Okay, so we've got our two two answers. This would become an ordered pair, negative 1, x is negative 1, y is negative 8. Okay, this is the solution system, right? So it's your solution. And again, you can check it. I would suggest that you do that, okay? For the very same reason I said before. If you want an A, check it. All right. Now, if we look at this problem here, we've got 9x plus 2y equals 0, 3x minus 5y equals 17. Well, this is 9 and 3, and this is 2 and negative 5. Those are kind of difficult numbers to deal with. The x's, well, I do see that 9 and 3, 9 is a multiple of 3, so that's helpful. But 2 and negative 5, it's not. But if I multiplied the bottom equation times negative 3, then I would have negative 9x, and that would be the opposite of the 9x in the top. So let's do that. So we're going to go ahead and multiply the entire equation, the second equation, times negative 3. All right? So I'm going to just put a double line here so that you know we're going to rewrite the equations again. So I'm going to rewrite the top equation, 9x plus 2y equals 0. And then I'm going to distribute the negative 3 to the 3 and to the negative 5 and over here to the 17. So negative 3 times 3 is negative 9, and it's x's, okay? It's negative 9 x's. Negative 3 times negative 5 y's, that's positive 15 y's, right? And let's see, negative 3 times 17. Negative 3 times 7 is 21. Carry the 2. Negative 3 times 1 is 5. And so it looks like it's going to be negative 51. Okay, negative 51. Now, if we aren't sure about that, and I'm a little bit unsure because I'm not always dealing with larger numbers like this, just get out your calculator. And so I'm going to take negative, what was it? It was positive 17. And I'm going to multiply that times negative 3. And indeed, it's negative 51. Okay? So combine the two equations now, all right? Okay, and so now we have some opposites. So that's what we want. We want to get opposite. Okay, so here's our opposites over here. So 9x and negative 9x cancel. And 15 and 2 makes 17 y's, and that equals 0, and negative 51 is negative 51. All right. So now I notice this is negative 51, this is 17, but this negative 51 came by multiplying negative 3 times 17, so it's probably 3 that I would be dividing these, or I'm sorry, I'd multiply 7, yeah, I'd be divided by 17, I ought to get negative 3, something like that. But let's find out. So I'm going to go ahead and take negative 51, and I'm going to divide it by 17. Right? Remember, we're dividing both sides by 17. Now on this left side it cancels, so we have y equals. But negative 51 divided by 17 is negative 3. Okay, so I was right. Negative 3. Use your calculator when you get that, okay? When you have problems like that. So here's your answer now, okay? So you're going to, again, pick an equation. And you're going to put the y into one of these two equations and solve for x. So pick an equation. One of the top two, and don't go down and pick one of these down here because you could make an error and you don't want to do that. So I'm looking at this and I say to myself, well, always go for the easier problem, one that is a little simpler. And 9x plus 2y equals 0 is a little simpler. It doesn't have as many large numbers in it. Okay? It only has one number that is larger. So let's use that. So 9x plus 2y equals 0. All right? So I'm going to plug in negative 3 here for my y. So I'm going to plug that in right here. So That means I'll have to have 9x plus 2 times negative 3. And that equals 0. So 9x, and let's see, 2 times negative 3 is negative 6, equals 0. Add 6 to both sides, and you get 9x equals 6. Now just divide by 9, and you get x equals 6 over 9. Now 6 over 9, if you look at that, 6 over 9, I think what you probably do is reduce it. You could multiply. See, this is 2 times 3 is 6. This is 3 times 3 is 9. So you could divide by 3 with both of these. So that would leave 2 at the top. So I'm going to divide by 3 here and divide by 3 here. 6 divided by 3 is 2. 9 divided by 3 is 3. So I get an answer of 2/3. Okay? Now, you know, this is a perfectly acceptable answer. Don't just decide that, oh, I must have made a mistake because I got a fraction. You will want to make sure that you check. So check. Plug these values for x and y back into each of these two equations, and see what you get. And what you should get is two sets of equations that equal each other. So when I put negative 3 and 2/3 in for 2/3 in for the x and negative 3 for the y, I should get a 0 over here. And when I do the same thing for the second equation, I should get a 17 over here. So 0 equals 0, 17 equals 17. Okay. All right. One last thing too, just helpful. Sometimes, you know, somebody can't do these fractions very well. If you have a graphing calculator like this TI, what you can do is you can take 6 divided by 9 and just literally divide it. 6 divided by 9, and you get this decimal. And if you want to know what the decimal is, all you need to do is you need to go over here to this math button that you see here, click it, and you'll see number 1, it says frac. That's what you want. I don't know if I have to scroll over one. No, I don't. Go back. So I just click enter. And so it says the answer, 0.67 in the frac, and then hit enter again, and you get, voila, the fraction 2/3. So that's good to know. You can also do the same thing with other calculators that are scientific calculators. You just have to know what they, you know, what calculator you've got and what its capabilities are. But I use TI-83s, and it's what I'm familiar with. Okay, one to go. So 6x minus 3y equals negative 3, and 8x minus 4y equals negative 4. Wow, looking at this one, I got the 8 and the 6 going here, and I got the 3 and the negative 3 and the negative 4 going here. These don't look like they're very easy to combine. So I'm going to just look at these two smaller numbers over here, and you know, I notice what I could do is, you know, I can either multiply or divide, but I've been using multiplication. If their least common multiple is probably, well, it is 12, I think. So that means if I multiplied this negative 3 times 4, I would get 12. If I multiplied negative 4 down here times 3, I would get 12. So what I'm going to do is I'm going to multiply the first equation here times 4, because 4 times 3 is negative 12, and the second equation by, I guess I want, I'm going to have it positive, I'm sorry, I'm going to have it negative, so negative 3, I'm sorry, negative 3, because negative 3 times negative 4 is positive 12. So this would give me negative 12. 4 times negative 3 is negative 12. And negative 3 times negative 4 gives me positive 12, because negative divided by negative is positive. All right, so I'm going to divide by Oh, well, we'll mention divisions, I think, in a little bit. I'm getting ahead of myself. So let's just distribute. So I'm going to go ahead and distribute the 4 to the negative 3, the 4 to the negative 3, and the 4 to the 6, and the negative 3 over here to the 8, the negative 3 over here to the negative 4, and the negative 3 to the negative 4. Okay? So I'm going to rewrite each of these equations. So 4 times 6 is 24. So I have 24 x's. Let's do over here. And let's just do this. Double line. And 4 times negative 3 is negative 12 y's. And 4 times negative 3 is negative 12. Okay? Then I'm going to multiply negative 3 times 8. That's negative 24x. Negative 3 times negative 4, that's positive 12y. And negative 4 times negative 3 is positive 12. Uh-oh. Look what's happened. 24x minus 24x, that's 0. It's eliminated. 12y, negative 12y, eliminated. 12 minus negative 12 and 12 is 0 as well. So 0 equals 0. Is that possible? Well, yes. So think back to when we were doing substitution and we got a situation like this. This meant that these are aren't they the same equations? Once we simplified them, we realized they're the same equations. So that means then that you've got infinitely many solutions. So this is true. You have infinitely many solutions. Okay? And that's because you have the same line. All right. Now, if you had something like, I don't know, 0 is not equal to 13, that would have been false. And remember, when you get situations like that, there's no solution. And that's a parallel line situation. So these are special circumstances. This is a special circumstance or special condition. And I was starting to see over here that you can divide by 3. And divide by 4. So in this case, I would divide this one by 3, and I would divide this one by 4. You could do that if you wanted to. So you can either divide or multiply. It would have brought you to the same place. Most people, though, are more comfortable with multiplication, so that's why we did it that way. All right. So keep it as simple as you can, and check your work. And you're bound to get an A in the test if you check that work and make sure it all works out. Okay? All right. We're done then, and have a wonderful day. We'll see you later. Thank you. Bye-bye.